It's not very often that you find such a high-performance aircraft hiding behind a hangar door at your local airport. But yet, here it sits, a Model 12 aerobatic airplane owned and operated by Ian Rowell. The Model 12 is now produced by 92nd West Aviation out of Lonoke, Arkansas, and is a two-seat, 170-mile-per-hour cruise, 3,000 feet per minute climb, and 300 degree per second roll rate, fully aerobatic hot rod of an airplane.
My name's Ian Rowell, owner of this beautiful Pitts Model 12. I actually bought it as a complete aircraft from a guy by the name of David Frasca. It was a Kimball-built aircraft. The Kimballs originally were the people behind the Pitts Model 12. The aircraft, I think, was completed and registered in 2010. I bought it in 2014. How I got to the Pitts was I'd been involved in general aviation for some time, and to be quite honest, I wanted something a little more exciting. And so I decided to venture into aerobatics as a more exciting option. The first thing I did was obviously to fly a tailwheel and a high performance aircraft, you need to have a tailwheel endorsement, and you also need a high performance endorsement. So I spent some time becoming familiar with tailwheel aircraft, flying a Decathlon, which is a wonderful little aircraft to learn to fly tailwheel on. Great lessons on energy management, really super aircraft to fly. And then transitioned from that on to the Extra 300, which is an absolute blast. I mean, it's an aircraft with tons of power. It's probably the most forgiving aerobatic aircraft you'll fly. Really easy to learn on. So I did the high performance conversions on that, and then spent about another, I would say about another 10 hours getting used to the Pitts Model 12, and then started flying the Model 12.
All right, Ian, so to back up just for a second, obviously you flew the Decathlon and the Extra and so forth. What was it like jumping from that into this, and did you get, I assume, some transition training in this model?
Yeah, it's quite different to the Extra 300, and it does require a little bit of more finessing, and that's why you need to do the transition from the 300 to the Model 12. Probably the most challenging part about the Model 12 compared to the Extra 300 would be landings. You've got this big honking radial up front. This aircraft, you have to do 3-point landings. You can't do any wheelies. That's largely due to the size of the propeller. So you do a 3-point landing. And obviously with that big radial up front, when you set yourself up for the landing, all visibility disappears from the front. So you've got to make sure your setup on landings is correct. That you're center on the center line for the runway. And then she lands beautifully. The 3-point is pretty easy to do, but you've got to set it up correctly. That's the biggest difference with the 300. The other thing would be in the verticals when flying this aircraft, you really do have to use a lot of left rudder. As you start to get adverse yaw, it's more pronounced in this aircraft than say when you were in an Extra 300. If you're doing hammerheads in this aircraft, it's less forgiving than an Extra 300, but it's way more fun. I mean, it really hones you in on your skills. You've got to put a lot of left rudder in to compensate for that adverse yaw. Once you kick right rudder in to do the hammerhead in it, you really have to be on your game with control stick inputs. So in those areas, it's a little more difficult than the Extra 300 to fly. But outside of that, it's as capable and as easy to fly as the Extra 300. Rolls, loops, spins, inverted spins. She flies beautifully. She's as gentle as you want her to be and as crazy wild as you want her to be.
Now
So
you mentioned left rudder, and most of us flying GA on departure will have right rudder. So does this engine rotate backwards, or is it just the way that the P factor works on this aircraft?
No, you're correct. I mean, it's got the Russian Vendeniev M14P engine in it, so it turns the opposite way, counterclockwise. So all of your inputs are the opposite of what you would be used to with, the typical Lycoming type engine, so left rudder inputs.
So on this aircraft, it'd be helpful to work out with a heavy clutch sports car to get your leg muscles built up to push the pedal in, huh?
Yeah, definitely. You know, when you take off on this, well, one day maybe we'll get to fly it, and I'll let you fly it. When you take off, you need a lot of left rudder.
Obviously, this is a unique aircraft. Where did you find a place to get transition training in it?
So it's quite interesting. The same spot where I did the decathlon and the extra 300 sort of training and conversions, there was a guy who was pretty skilled up, multiple ratings and licenses, and I used a guy, Larry King, who's very well known to the Model 12 fraternity, to come out and check this guy out. He checked him out in my aircraft, and then he did the transition training for me.
We are partnering with great companies like Dynon Avionics at Dynon.com, Airtech Coatings at airtechcoatings.com, Clemens Insurance at clemensinsurance.net, The Aviators Clinic at aviatorsclinic.com, Diamond Doors at diamonddoors.com, Flying Eyes at flyingeyesoptics.com, Foxtrot 95 Calhoun County Airport at flyfoxtrot95.com. Take a moment to go visit their websites at the links found below in the description of this video. And visit our website at experimentalaircraftchannel.com for events, our video library arranged in easy-to-find playlists on specific topics, affiliate products, aviation merchandise, and so much more.
So it's a 360 horsepower Vendenia, the M14P engine. It's the one that you find in the Yaks. There are different variations of that. You can do a Barrett conversion, which takes you up to, I believe, 460 horsepower. But this is the stock standard Russian engine, so it's at 360. Typically, if you want to know rotation speed, I mean, I don't even look at rotation speeds, to be honest with you. You know, you apply power gradually for takeoff. The power comes on quickly. It pushes you back in the seat. There's that much power. And it flies itself off the ground. Essentially, the stick will start moving forward. You let it move forward gently. You block it when it gets to the center. And it'll fly itself off the ground. So you're rotating when it's ready. Climb out, best speed for climb is 100 miles an hour. So as soon as you hit 100 miles an hour, you really need to pitch it up, because before you know it, you're at 120, 130 miles an hour. I mean, it's a rush. This thing gallops like you can't believe. You'll be at 100 miles an hour within, takeoff is probably, I want to say, 300 feet, if that. You're already off the ground. Obviously, you'll stay in ground effect for a little bit, and then the speed climbs. You've got to watch that you don't bust through the traffic pattern altitude, because it just moves. It really does. So you've got to come back on the power and reduce propeller RPM to 2,400 RPM, and then you can climb out at about 120 to 130 miles per hour. That's kind of the climb speed. For aerobatics, it depends on the maneuvers you're going to be doing, but again, 2,400 engine RPM, or prop RPM, not prop RPM, engine RPM. Probably for aerobatics, 36 inches of manifold pressure is where you're going to be sitting. It's full throttle. If you're going to do aileron rolls, you know, typically you can go into an aileron roll at 120 miles an hour. If you're going to do loops and that, I go in at 160 miles an hour and then pitch you up. Try and maintain 4 to 4.5 G in the loop. Hammerheads, it doesn't really matter. This thing climbs like a tractor. You know, I will go in at 140 miles an hour, pitch her up into the vertical, and hold her until around about 50 miles an hour. You can feel it starts to slow down before it stalls, before I, you know, move into the actual hammerhead maneuver. Half Cubans, Cuban 8, same thing, 160 miles an hour. Knife edge, the higher the speed, the cleaner the knife edge, the more easier, for me at least, easier to control. So normally a knife edge I'll do at 140, 145 miles an hour, but I don't go more than 180 for any maneuver. It depends on the type of maneuver you're doing.
And what is this stressed at?
So, you know, there's obviously always a fudge factor, but it's stressed at 7.5 and plus, and then I think it's 5 or 4.5 negative. But, you know, there's always a fudge factor to that. You can go a lot higher than that. I don't. I try to keep it within that range. The highest I've done is about 7G, but it's not sustained. 7 plus, you know, it's on and off. Just unload it as soon as the G gets too high.
All right, let's talk about the wing for a minute. You mentioned this is the shorter or clip wing, and what does that do for you for performance?
So, I mean, they're both symmetrical wings, first of all. So, you know, that makes a significant difference in performance, especially for inverted flight. The wings are shorter than the plans-built Model 12. This is what they call the HP kit. So it's the high-performance kit. The wings have been shortened to increase the roll rate. The stated number is 300 degrees a second, which is quite a fast roll rate. To be honest, I don't think I've ever done 300 degrees a second. I'm probably averaging maybe 270 degrees a second. I suppose it depends on skill level and circumstances what the roll rate is. But theoretically, you should do 300 degrees a minute.
And with that attitude, I assume when you're ready to get into a roll like that, you're literally almost punching the stick through the side of the fuselage when you do that snap.
Yeah, you're putting it, you know, it's as fast as you can move the stick from the center to the left or the right, depending on the roll. You have to put a bit of rudder in quite quickly, on off, to compensate for that roll, otherwise the tail flicks out. But yeah, you go as quick as you can with that stick and it'll roll as fast as you can move the stick.
And the aerobatic aircraft, I can assume that you don't need to load up with a whole bunch of glass panels and stuff like that just to go have fun. So what is this equipped with, and what is your thought process as far as what it is equipped with in any aerobatic aircraft?
Well, I think the challenge with aerobatic aeroplanes is always weight. So, you know, when you're going to think about a cockpit layout, you want to minimize the amount of weight that you have to carry. Any additional weight's going to take away from performance. So you have minimalistic type instrument panels typically for an aerobatic aircraft. This aircraft originally, you know, had a very minimalistic instrument panel. I've changed it, I upgraded, I put an electronic EFA system in. Kind of actually came out at more or less the same weight, but a lot more functionality than what I had with the old steam and pressure gauge type functions that I had in it before. So yeah, mine's a full EFA system. So you know, I have moving map displays. I have specific dedicated custom designed engine displays that come up very easy to use, sort of intuitive, not complex like some of these other systems, and that's essentially what I have. I have some backup systems. I obviously have airspeed indicator, which is the classic airspeed indicator configuration. I have an altimeter, same thing, a G meter. Those are all traditional analog type gauges, and that's about it that I have in the aircraft.
And then, of course, with all aerobatic activities, most of you all wear a parachute. Do you have a preferred brand that you like, whether it's more comfortable or you feel safer with it or whatnot?
So I have a Butler parachute. You know, to be honest with you, didn't really have a preferred brand of parachute. Larry King, who services my aircraft, has a lot of experience with the Model 12, and he recommended the Butler, primarily because they're able to configure the parachute so that it fits into the seat design that comes with the Model 12. These are carbon fiber seats, and so the parachute is actually configured and built so that it fits back into the recess of the actual seating arrangement, and that's essentially why I bought the Butler chute.
All right, and you want to show everybody what it's like to climb into one of these beasts?
I will do.
And down. Not too bad.
Pretty easy.
Not too bad. All right, so what we're not going to start today, but what would be the startup procedure for this particular radial engine?
So obviously use the start checklist, but I'll go from memory. Obviously the pre-flight will be completed. You would have pulled the prop through. You count 19 blades. That's to make sure you don't end up with hydraulicking. It's a radial engine. You have an oil drain point in the front on the engine. You have to shut that off. Make sure that's off. You've got to open the air. This is a pneumatic start system, so it's not an electric starter, it's pneumatic. It's actually really cool if you see how it works. It's actually an amazing piece of technology. So open up the air valve, close all your flaps. When you're in here, it's master on, avionics on. Okay. Fuel flow lever, fully back, prop on high pitch. What's interesting here is you'll see there's no mixture on this aircraft, and the reason there's no mixture is because this has a pressure carburetor, so it adjusts the mixture based on changes in altitude, the pressure related to altitude, so that adjusts your mixture automatically. It's a good and it's a bad thing. It's good because you don't have to fiddle with a mixture all the time. It's not a good thing during startup, and that's because being a radial engine, you can get oil on the bottom cylinders. And once you start it up, if you had a manual mixture setting, you could lean it out and burn the oil off quite quickly, so your mag drops are more consistent. With a pressure carburetor, you don't get that. You can't lean it out and burn any excess carbon or oil out that easily by leaning it. So sometimes you have to take a little longer on the run-ups to burn it clean, so you don't get significant mag drops. Anyway, it would be master on, fuel flow fully back, prop on high, the avionics is obviously on. You would move to your primer cycle over here. Okay, you activate the primer. It starts a booster pump which pushes fuel into the supercharger. You do that for 8 seconds. You shut it off. Then you advance the fuel flow lever to quarter open, and then you move to your starting cycle. You would flick the start button. It opens a solenoid valve which then directs the air into a distributor, which then brings air into the top of the pistons, forces them down, and that turns the engine. She will fire once, and then you flick the magnetos on, and then she'll fire up all the way through. Watch oil pressure and oil temperature. You got to hold her at idle to 1000 RPM until you get to 104 degrees Fahrenheit, and then you can advance it to do your mag checks and your prop checks after that. That's the starting cycle. Pretty simple. To shut the aircraft down after you've flown, you don't have a mixture control where you pull the mixture out and it shuts down. You shut it down using the mags. So you just drop the mags into off position and it shuts down.
To learn more about the Model 12 aircraft or to order a kit, give Don a call at 92ndwestaviation.com. Thanks for watching this week's episode. Remember to like, subscribe, and hit that bell notification so you don't miss a single episode.